And now we're going to talk about solving chemical problems. A lot of chemical problems come down to being actually unit conversion problems. And this method called dimensional analysis, I learned this as a junior in physics class in high school. And it's probably the most useful thing I learned in all of high school, was how to manipulate the units. My physics teacher told us you can actually fudge your way through a lot of physics problems by just putting the numbers you're given together in a way that the units work out. And that's actually true in some chemistry problems as well. Units are actually your friend. They will help you solve the problems. So always include the units. They are part of the number. So if you've got a unit and a number, you need to write them both down all the time, okay? Units can be manipulated like variables in algebra, like x's and y's. They can cancel out, they can get squared or cubed or whatever. So they act just like variables. So when we're converting a unit, a number from one unit to another, we need some relationship between those two units. And that's often called a unit equation. Issues. Okay, here it is. iPad and the computer are like on different pages, literally. So here we have the relationship 2.54 centimeters is equal to 1 inch. An inch and 2.54 centimeters are the same distance. They are just different names for the same thing. And we can make a conversion factor out of this unit equation. A conversion factor is usually expressed as a fraction where we have one unit on top and the other unit on the bottom. And so we can take this relationship, 2.54 centimeters equals 1 inch, and when we have an equality, if we do the same thing to both sides, they're still equal. So I could divide both sides. I'll choose to we'll divide both sides by 2.54 centimeters. Because I did the same thing to both sides, they're still equal. And I look over here, 2.54 divided by 2.54 is 1. So those cancel out, that's just 1. And centimeter divided by centimeter cancels out as well. So the result here is that this 1 inch divided by 2.54 centimeters is numerically equal to the number 1. That means that 1 inch is equal to 2.54 centimeters. I could have done it the other way around. I could have divided by 1 inch. Then I would end up with blanking, 2.54 centimeters on top and 1 inch on the bottom. That's also equal to 1. You believe it? Okay with that? These are the two conversion factors that I can make from this relationship. Because they're both numerically equal to 1, if I take some other quantity and multiply by one of my conversion factors, it's the same as multiplying by 1. It doesn't change the quantity. And that's the whole idea behind dimensional analysis. So most of these conversion problems are going to take this form. There's some information given, a particular unit that they're saying, okay, like here, how many centimeters are in 12 inches? Well, 12 inches is the given unit. And then there's some information that you're seeking, a desired unit. This question asked how many centimeters? Well, that's the desired unit. And to get from inches to centimeters, we need a factor in here. And we're going to put the given unit in the bottom and the desired unit in the top so that the units cancel out. So let's do that with this example. The given unit is 12 inches. We're going to be multiplying by a conversion factor. We want to end up with centimeters. So if I multiply by centimeters and divide by inches, the inches will cancel out. they'll go away. And I'm left with centimeters, the unit that I want. Everybody okay with that? But a centimeter is not the same as an inch. I need the numerator of my fraction to be numerically equal to the denominator. I need those to be the same length. So we just talked about that one. 1 inch is 2.54 centimeters. At first you might not remember that, but you can look it up. 1 inch equals 2.54 centimeters. Well, I've got centimeters on top. I'm going to take the side with centimeters and put that on top. Inches on the bottom, the number with inch is 1. So now I've got 12 times 2.54, and the calculator is going to tell me 30.48. Any questions about the unit conversion? How should I report that number considering significant figures? How many significant figures does 12 inches have? 2. It looks like a nice whole number, right? But it's a measurement. It's only got 2. 2 sig figs. What about this thing here? That's exact. It's defined. So if it's exact, I can just forget about it. That's not going to limit my answer. So this has 2. My answer should have 2 significant figures. And so that's going to be 30. Now I do need a decimal point there. 30 centimeters. Or what's better is to put this into scientific notation. So I'm going to move the decimal point so that it's after the first non-zero digit. I want to keep that 0 because it's a significant figure. And I'm going to multiply by 10 to the something, and then I'm going to look at how many places did I move the decimal point. I moved it from here to there, 1 place. So the exponent is 1. The unit is centimeter. The sign of the exponent can be tricky. Look at the original number. Is that a big number or a small number? Small meaning less than 1. It's a relatively big number, right? So big number, positive exponent. So it's 3.0 times 10 to the 1. Yeah.
So if there was a quiz and we left it at 30, that would have been wrong.
So if there was a quiz and I was testing you on significant figures, 30 would be wrong. Now, the real goal that I have for you with significant figures is that you become comfortable with them and you can report answers with an appropriate, a reasonable number of digits. I'm not going to always count things wrong if you don't have it exactly correct. On the first exam, there will be questions that are specifically about significant figures. You have to get those right on. The rest of it, as long as you're close, I'm okay with that. I'll probably correct it, but I won't necessarily take points off. Okay, so just do your best. So this whole problem solving is something that a lot of students struggle with, and you can get better at it. Some people are naturally good at it. They find word problems to be fun. Other people hate them, and there's usually no middle ground. It's one or the other. So if you're a person who doesn't like word problems, I'm sorry, there's a whole bunch of word problems in chemistry. There's word problems in life too, but you can become better at it. You just have to ask for help. Okay? So some ideas of how to solve these: identify the starting point, identify the end point. It's a little bit like going to the mall. I went to the Stanford Mall a couple years ago. I was supposed to meet somebody at Starbucks. That mall is like sprawling all over the place. I had no idea. So you park the car, you get out, and you find one of those kiosks with a map, right? And the first thing you do on the map is you have to find out, where am I? And there's usually a red dot that says, you are here. Oh, thanks. There I am. So you find out where you are, where you're starting, and then you have to figure out, where am I going? You can't start going until you know where, right? So I'm trying to get to Starbucks, so I find it on the map. And then I can figure out, oh, I need to go down here and take a left and then go over there and take a right. And I can make a path. And that's the same strategy that you can use for most of these problems. What am I given? What am I starting with? What am I trying to find out? And then figure out how am I going to get there. Okay? Metric prefixes. So conversion factors with metric units are very easy if you have those metric prefixes memorized or you have the table handy. So we just substitute the prefix with the times 10 to the whatever that it means, right? So here, if we want a relationship between kilometers and meters, 1 meter is equal to 1 times 10 to the, what does kilo mean? 10 to the 3. We use a lot of scientific notation in Chem 1A. If you are unfamiliar with that, I think there's an appendix in the back that goes over that. I'd be happy to review it with you, but I'm not going to lecture on scientific notation. So there are other ways to express this, but this is the pattern that always works, and so I'm going to do this consistently in lecture. If we have 1 centimeter and we want to know how many meters that is, what does centi mean? 10 to the negative 2. That's 1 times 10 to the minus 2 meters. Now some of you will say, well, I learned that a meter is 100 centimeters. That is true. That's true. But sometimes people tell me that a centimeter is 100 meters because they forget which number goes with which unit. That's like saying that an inch is 12 feet, right? It's ridiculous. But because you're not real familiar with the metric system, you can make mistakes like that. So if you follow this pattern where the prefix goes on one side and the 10 to the something goes on the other side, it'll always be right. I'm a big fan of always right. Okay, so if you can do it the other way, great. You don't need my help. If you're struggling with it, follow this pattern and it will come. So what if we're converting between, say, centimeters and nanometers? Both of the units have prefixes. There are other ways to do this, but I don't think they're very good, so I don't recommend them. If you have 2 prefixes, you're going to do it in 2 steps. So centimeters to nanometers, you're going to go to the base unit in between. So you go from centimeters to meters, and then meters to nanometers. It's an extra step, but it's a lot less thinking. If you try to come up with a conversion between centimeters and nanometers, that usually doesn't go well. It makes my head hurt to do it. I'll just do the 2 steps. Okay, let's do some practice. So convert 288 centimeters to yards. So this problem doesn't have very many words. We're just focusing on the unit conversion. But what's my starting unit? Centimeters. That's the thing that has the number with it. And what am I trying to find? Yards. So I identified where I'm starting, where I'm ending, and now I have to figure out how I'm going to get there. There are different ways that you can get there. Some are easier, some are harder. It depends on what information you have. Now, you could ask Google or Siri for the relationship between centimeters and yards. I don't recommend that, though. We need to learn how to combine things and put stuff together. So what do we know just out of the top of our head that's between centimeters and yards? Meters? Okay, we might use meters. What else might be useful? Feet. So we know how many feet are in a yard, right? So let's just kind of collect things that we know. There's 3 feet is equal to 1 yard. Anybody know the relationship between a meter and a yard? I don't. I don't know the relationship between, well, I know meters to centimeters, but because meters to yards, I don't know. it's not going to be very helpful to me. So this one tells me that if I got to feet, I could get to yards. So let's put feet right here. And so now I'm trying to figure out how to get from centimeters to feet. Inches. Okay, we've talked about that one. 2.54 centimeters equals 1 inch. So if I've got centimeters, I can get to inches, and then from inches I can get to feet. Right? Because there's 12 inches is equal to 1 foot. So I made that path based on things that I had the information for. Each of these arrows is a step. I need to know the numerical relationship between those two units or it's not going to work. So I could have gone centimeters to meters, but then because I didn't know meters to yards, that wasn't going to work for me. If I had it readily available on a piece of paper, then I could do that too. There's lots of different paths you could take, but this is the one we've come up with. I'm going to erase these guys so that it doesn't get confusing. This is the hardest part, right there, figuring out the path. Once you get that, the rest of it is following a pattern. What we're going to do is for every arrow, we're going to have a conversion factor fraction. So I have 3 arrows. I'm starting with centimeters. I'm going to go ahead and put the number in there now. 288 centimeters. I see 3 arrows, so I'm going to write 3 fractions. 1, 2, 3. What do I put in there? Well, I'm going to follow my path. Centimeters to inches to feet to yards. Centimeters to inches to feet to yards. I'm basically copying my path into my equation. The units in the path are the units in the numerator. That was easy enough, right? Well, now I've got a whole bunch of units multiplied. I need to get rid of them, right? I just want yards left. So how do I get rid of centimeters? I divide by centimeters. So I'm going to divide by centimeters there. The centimeters are going to cancel out. And then here I want to divide by inches, so the inches cancel out. And then I'm going to divide by feet, and the feet cancel out. Okay? This is dimensional analysis, unit analysis, because we're using the units to tell us what to do. Now that I have all the units in place, I can put in the numbers. And the numbers are going to come from these relationships that I know or have looked up. You don't have to write these down, but if you're struggling, it's helpful. So here, inches and centimeters, I just need to be sure that the numerator is equal to the denominator. So I know that 1 inch is equal to 2.54 centimeters. So 1 inch is 2.54 centimeters. The top equals the bottom. When you look at the written unit equation over here, the 2.54 centimeter is on one side of the fraction line, the 1 inch is on the other side of the fraction line. Don't switch the numbers in the units. Okay? So here, with feet and inch, what number am I going to put with feet? 1. And 1 foot is how many inches? 12. So 1 foot equals 12 inches. The top equals the bottom. Because this is like multiplying by 1. It's just we're changing units. Yards and feet. What numbers go in there? 1 and 3. 1 yard is 3 feet. You see how that works? Is that hard? No. So we want to get comfortable with this when we're using units like this that we're kind of familiar with, because later we're going to use some other things like moles of hydrogen and grams of permanganate and stuff. And then if we're comfortable with the technique, the different units aren't going to bother us, okay? So yes, you could do this a different way, but we want to learn the process. So now that we've gotten that all written out, there's no need to multiply and then divide and write stuff down. Sometimes students want to take the numerators and multiply them all and write that down and then divide by all of these. This is what I highly, highly recommend. Just start at the left and go to the right. So it's this times the top, divide by the bottom. times the top divided by the bottom times the top divided by the bottom equals. There's your answer. Now, obviously, you don't have to multiply by 1, right? So when I do this 2.88, I divide by that, I divide by that, I divide by that. Some people are bothered by that. If you want to multiply by the 1 because that's clearer to you, you go right ahead. It's not going to mess anything up, okay? So I'll just do it that way. 288 times 1 divided by 2.54 times 1 divided by 12 times 1 divided by 3 equals. And the calculator gives me this big old mess. 3.1496, and I'm like, I don't want to write all this down. Okay, so before I get into all of that, how many significant figures should my answer have? 3. Very good. I'm starting with 3. This is an exact relationship. Exact. So I'm starting with 3. I'm going to end with 3. The 3.14. Don't round it yet. You might end up needing this number later, or you might want to check your work and realize that you rounded incorrectly. So what I recommend is write down what your calculator gives you, showing as many sig figs as you need and 2 extras. If you want to write the whole thing down, that's fine, but I get tired of that. So I'm going to write it down like this, yards, and then I'm going to round it, and this is 3.15 yards. Any questions? Convert 9,255 cubic centimeters to gallons. So this just popped up here because I don't ever remember this one. But this is from the table. 1 gallon is equal to 3.785 liters. So approaching this problem, we look at our given unit, that's the one with the number, and the unit we're trying to find. So I'm starting with cubic centimeters. That's the red dot. You are here on the map, and I'm trying to get to gallons. Some of these are 1 step, some are 2, some are like 5 or 6. Cubic centimeters to gallons. Okay, so these are volume units. We've got this here, so I know I could do gallons to liters. So here's gallons. That means if I got to liters, I could get to gallons. Sometimes you work backwards, sometimes you work frontwards, and sometimes you work from both ends and hope that you meet in the middle somewhere. It can be, this is the hardest part, is figuring out how to get from A to B. Okay, so cubic centimeters to liters. Milliliters, right? So milliliters to liters, that's just a metric prefix thing. What's the relationship between cubic centimeters and milliliters? It's 1 to 1. They're the same. Okay, that's that one that is often overlooked. 1 cubic centimeter is the same as 1 milliliter. Different names for the same thing. It's also called a cc by people in the medical profession. So I've got that relationship. Let's go ahead and write down the relationship between milliliter and liter. So 1 milliliter is equal to 1 times 10 to the something liters. What does milli stand for? 10 to the minus 3, because it makes it smaller. So any questions so far? So I've got three arrows again. I'm going to have 3 fractions. 9,255 cubic centimeters. Times in a line, times in a line, times in a line. The units in the numerator are just the ones I wrote out in the path. Cubic centimeters to milliliters to liters to gallons. I got the path. All I have to do is copy it down. The unit in the denominator is just whatever the previous unit is. So cubic centimeters down here, and those will cancel out. Milliliters, and those will cancel. And then liters, and those will cancel. Okay? Get all the units in first, and then put the numbers in. So I've got this guy right here. 1 gallon goes on one side, 1 gallon, and 3.785 liters goes on the other side. 1 cubic centimeter equals 1 milliliter, so that's just 1 and 1. 1 milliliter is 1 times 10 to the minus third liters. So 1 milliliter, 1 times 10 to the minus 3 liters. Any questions? Now this number, how do we put that into our calculators? You need a scientific calculator for this class, so it should have an EE or an EXP button on it. And if you're not sure how that works on your calculator, please ask me when we get to working on the worksheet. There are other ways you can enter it, but they are fraught with peril. So trust me, get to know the EE or the EXP button. So what I'm going to do here is 9255 times 1 divided by 1 times, and now to enter that 1 times 10 to the minus 3, I'm going to go 1 EE negative 3. And then I'm going to divide by 1 and multiply by 1 and divide by 3.785 equals. My calculator is showing me a number. I want to think ahead so I don't have to write down a whole bunch of garbage. This relationship is exact. This one is exact. This one is not exact. The relationship between gallons and liters, those are in different systems. So what this is saying is that exactly 1 gallon is equal to 3.785 liters with uncertainty in that 5. So we think of this as having 4 significant figures. We're starting with 4, so our answer should have 4. So I'm going to write down the first 4, 2.445, and then the next 2, 17. The beauty of keeping 2 instead of just 1, you don't have to worry about rounding up or down. You can just write the digit. I know the next one would cause that 7 to round up to an 8, but it doesn't matter. It's fine. And then we'll round. We're going to drop this digit. That's a 1. And so this is 2.445 gallons. Any questions? Sometimes we need to convert units that are raised to a power. So area or volume units, cubic centimeters, square meters, things like that. When you're building the conversion factors for this, you have to use the power on the unit and the number. So if we're looking at square inches to square centimeters, we know this relationship between centimeters and inches. You're not going to find a square centimeters to square inches relationship because we just make it out of this one. So if we want square centimeters, I'm going to square this side and I'm going to square that side. I have to square the number and the unit. Okay? So 2.54 squared, you can just do that on your calculator, or if you want to write it out, you could call that 6.45 square centimeters. Over here, the 1 squared is still 1. So just a quick look at why we have to square the number. So this is a square that's 1 inch on a side. What's the area? 1 square inch, right? Well, 1 inch is the same as 2.54 centimeters. So this is also 2.54 centimeters on a side. Now, if I calculate the area, 2.54 centimeters times 2.54 centimeters, is that 2.54 square centimeters? Nope, it's 6.45. So this is 2.54 squared square centimeters, or 6.45. So squaring or cubing units, you start with just your regular conversion factor, and then square or cube all of it, including the number. How many cubic centimeters are there in 2.11 cubic yards? Well, we're going to approach this the same way. Where are we starting? Where are we ending? So they're asking for cubic centimeters, and they're giving us the number of cubic yards. So cubic yards is where I'm starting, and cubic centimeters is where I'm going to end up. So when finding this path, start out by just ignoring the cube part. How do I get from yards to centimeters? Well, we did that the other way, right? We went from centimeters to yards, and there was just so many steps. Let's just throw in a shortcut. 1 yard is equal to 36 inches, right? Sometimes we kind of forget that, but a yard is 36 inches. So we could go directly from yards to inches, and then we know the relationship between inches and centimeters. So then we can do it if those are cubed. If they're cubed as well. So here I made a path that has two arrows, so I'm going to have two fractions. So I got 2.11 yards cubed times in a line, times in a line. I just copy the units that are in my path. Cubic yards, cubic inches, cubic centimeters. Just following a pattern. I want to get rid of this unit, so in this fraction I'm going to divide by cubic yards, because cubic yards divided by cubic yards is 1, cancels out. And then cubic inches down here, and that cancels out. Okay? So the relationship between inches and yards we have written up here. 1 yard is 36 inches. 1 yard is 36 inches. But a cubic yard is not 36 cubic inches. We have to cube the numbers also. So this is going to be cubed, and this is going to be cubed. That's important. Centimeters and inches, 2.54 centimeters to 1 inch. These units are cubed. The numbers have to be cubed. Now, obviously, 1 cubed is just 1, right? You can do the math here and write out the value. I like to just use my calculator. I can raise things to the 3rd power on my calculator. So I'm going to go 2.11 times 36, and then there's an X with a superscript box. I press that, and I get a 3. And then times 2.54 to the 3rd power, and I press equals. And I get this really, really long number. Anybody else get that number? You're like, whoa, that's like a really, really big number. We haven't gotten numbers like that before. Did we do something wrong? Well, let's think about it. A cubic yard. A yard is about the same size as a meter. We saw that picture of me sitting in that box, right? It's a big box. This is 2.11 cubic yards. That's a big area, right? Or, I'm sorry, volume. Big volume. And we're converting it to cubic centimeters. The cubic centimeter is a little tiny thing. So yeah, it's going to be a big number. How many significant figures should this have? 3. This is exact. That's exact. 2.54 centimeters to 1 inch is exact, because we defined it that way. So this has 3. This has 3. So I'm going to keep 1, 6, 1. So when I round that, I have to be careful, right? Because that's what, 1,613,210.75? I don't want to round that to 161. That would be silly. So I can do it this way, 1, 6, 1, because it's 3, I'm rounding down. And then I need to replace all of those things until the decimal point with zeros. That's an okay answer, acceptable. The best thing, though, put it in scientific notation. In scientific notation, we put the decimal point after the first non-zero digit. So there's the 1 decimal point, and then I write down my other significant figures, 6 and 1, times 10 to the something. So I'm going to count 1, 2, 3, 4, 5, 6. I moved it 6 places. So my exponent is 6. And then I have to decide, is it positive or negative? I look at that number. Is it a big number? Yeah. Guess how I feel about big paychecks. Positive or negative? Positive. I feel positive about big paychecks. The exponent is positive for big numbers. It's negative for small numbers. So it's a positive 6 cubic centimeters. That's the best answer, but the one above it is okay. Any questions?
Do you still express it as a metric prefix?
No, you wouldn't express this as a metric prefix because this already has a prefix. And because this unit is cubed, then things are going to get all messy. Yeah. And the point of the thing was cubic centimeters. That's a good question. I hadn't thought about that. Anybody else? So we talked a little bit about density, and we calculated the density. We have an equation. Density is mass over volume. When you're calculating density, you have to use the equation. If you're calculating volume or mass, don't use the equation, unless you're a whiz at algebra. People try to use the equation and rearrange it, and they do it wrong, okay? And using density as a conversion factor is easier once you get used to it, okay? So that's what I'm going to show you here. So here's the story. Backpackers often use canisters of white gas to fuel a cooking stove's burner. If one canister contains 1.45 liters of white gas and the density of the gas is 0.710 grams per cubic centimeter, what is the mass of the fuel in kilograms? Okay, lots and lots of words. Pull the numbers out. Because we can't really tell where we're starting until we look at the numbers. So I've got 1.45 liters, and I've got 0.710. That fraction is written with a slash, and it's horizontal. It's in line with the text, because that's a lot easier to do on the computer. But when you do that and you write it out by hand, your brain doesn't recognize that as a fraction. So take that and write it as a vertical fraction. That is grams divided by cubic centimeters. And you might as well just extend the line all the way over there. So those are the numbers. So I'm going to start with one of those. Maybe I'm not sure which one yet. What am I trying to find? Mass in kilograms. Okay. Well, looking at these, this is just a single unit. This is a derived unit. It's grams per cubic centimeters. That sounds a lot like a conversion factor, doesn't it? 1 inch per 2.54 centimeters, something like that. This can be used as a conversion factor. This cannot. So this is the one we're going to start with, and we're going to use this as a conversion factor. This gives us the relationship between grams and cubic centimeters for this problem. That is not always true, 0.710 grams per cubic centimeters, but it's true for this. Okay, so I've got liters and I've got kilograms, and the only thing I've got so far to bridge the gap is grams and cubic centimeters. Well, I need to get gram in here somewhere. If I had grams, I could get to kilograms, right? Grams and kilograms. And this density here allows me to convert from cubic centimeters to grams. But liters to cubic centimeters, milliliters. Liters to milliliters, milliliters to cubic centimeters. Oh my goodness, there's four arrows. It's okay. 1.45 liters times, that's milliliters, times with cubic centimeters, times with grams, and times with kilograms. If you're struggling with these sorts of problems, you should absolutely write down the path. And perhaps all the unit equations that go with that. If you're getting the hang of this, you don't necessarily have to write that down, but I do want you to write this stuff down. I want you to write out the whole thing with the units and show how they cancel out. It'll help you later. So I copied the units from my path. Now I'm going to divide by the previous unit. Liters divide and cancel out. Milliliters cancel. Cubic centimeters cancel. And grams cancel. Now I go looking for numbers to stick in here. I get all the units in there first. The units then tell me where to put the numbers. I don't have to think about, was I supposed to divide or multiply by this? It's just going to tell me. This one's easy, or should be, once you remember it. A cubic centimeter and a milliliter are exactly the same thing. So the numbers for that one are 1 and 1. And then we might look at this one and say, well, I know what milli means. Milli means 10 to the minus 3, right? So 1 milliliter is 1 times 10 to the minus 3, because this is what milli means, times 10 to the minus 3. And then over here I've got another just prefix conversion. Kilo means times 10 to the plus 3. So 1 kilogram, 1 times 10 to the positive 3. And then this guy in the middle, that's where we're going to use the density. The number goes with gram, so I'm going to put the number here with gram. And the cubic centimeters in the bottom. If it bothers you that there isn't a number down there, it would be 1. So now we're just going to go across from left to right, do multiply by the top, divide by the bottom. 1.45 times 1 divided by 1 EE negative 3 times 1 divided by 1 times 0.710 divided by 1 times 1 divided by 1 EE3. It didn't give me a whole big mess, it just gave me that. Anybody else get that? If you're getting something very different, you're probably doing something wrong with your scientific notation and your calculator's not understanding what you're trying to tell it. How many sig figs in the answer? 3. We're starting with 3, 1.45. Exact, exact, not exact, exact. And this one has 3 sig figs. So 3 sig figs, and our unit is kilogram, 1.03 kilograms. Any questions? Sometimes you do have to use an equation, and sometimes you combine equations with dimensional analysis. When you've got an equation in a problem, you'll usually have one variable that you need to solve for, and you'll be given either the other variables or the information you need to find them. So an example of a problem using an equation is this one. Find the radius of an aluminum cylinder that is 2 centimeters long and has a mass of 12.4 grams. For a cylinder, the volume equals pi r squared L. Well, let's pull out the numbers. We've got 2.00 centimeters, and we have 12.4 grams. And we got that equation. So this 2 centimeters, is that one of the variables in the equation? What's the L stand for? Length? How long is the cylinder? 2 centimeters, right? So this is the length in the equation. We're trying to find R, right? And so we know what L is. We're trying to find R. Pi is just that button on your calculator, but we don't have the volume. Is this the volume? No. What is it? It's mass. We need the volume. Let's go ahead and rearrange the equation because we're like, I know I'm going to have to rearrange the equation. I'll do that, and then maybe I'll feel better about the rest of it. Volume equals pi r squared L. There is algebra in Chem 1A. Okay? If you're rusty on it, please ask me for help. Okay. You got through it once. You can do it again. So we want to isolate R. So I need to get rid of pi and L. And these are multiplying R squared, and so to get rid of them, I'm going to divide by them. I'm going to divide by pi. Pi over pi is 1. It cancels out. If I do it to one side, I have to do it to the other side, or it won't be equal anymore. So I'm going to divide this side by pi also. To get rid of the L, I'm going to divide by L. The L's cancel out. I have to do the same thing to both sides. You've got to be fair. Divide by L. So we're getting closer. What I have now is R squared is equal to the volume divided by pi and L. But I want R, not R squared. How do I undo a square? Square root. So if I take the square root of both sides, the square root of R squared is R. So I end up with the equation in terms of R. R is the square root of the volume divided by pi and L. Okay, so we made some progress, but we still don't know what the volume is. There must be a way. I've got a mass. Do we know what this is made out of? Aluminum. I forgot to pop this up earlier. We would look that up, the density of aluminum. 2.70 grams per cubic centimeter. Density equals 2.70 grams over cubic centimeters. It's a fraction. It's a conversion factor. Sometimes you're not given all the information in the problem. You have to go look for it somewhere. It should be in your book. You shouldn't have to scrounge too hard for it. Okay, so I'm trying to get the volume. Now, I could use the density equation, but again, people screw that up a lot. So let's just use the density as a conversion factor. I have grams, and I want volume. So this density has grams and cubic centimeters. Is cubic centimeter a unit of volume? Yeah. So grams to cubic centimeters, 12.4 grams if I multiply by cubic centimeters and divide by grams. I can convert the mass into a volume. I can also convert volume into mass if I have the density. I have the density, 2.70 grams. 2.70 grams happens to be in the denominator this time. 1 cubic centimeter. So 12.4 divided by 2.70. Calculator's given me a big old mess. How many sig figs will this result have? 3. So I'm going to write down 3 and 2 extras. 4.59, there's my 3 sig figs, and the next 2 digits, 25. And the unit is cubic centimeters. That is the volume. That's a good question. Don't we round something up here? We don't want to round it yet because, well, and, are you asking about the 259? Are you asking about this next digit that's a 9? Yeah. So you can round that 5 to a 6. It's not going to matter though. Okay. That's kind of why I came on using 2 extra digits, because then you don't even have to think about whether you should round it or not. You can just write down the 2 digits and it'll always be okay. So I want to carry those 2 extra digits because I don't want to introduce rounding errors. So now I have everything I need to put into my equation. The radius equals the square root of the volume, 4.59. I'm going to underline that 9 to remind myself this number has 3 sig figs. 25 cubic centimeters divided by pi. There's a pi button on your calculator. Don't round that to 3.14. There's a whole bunch of other digits, and your calculator will do plenty of them. Just use the pi button. And then the length, 2.00 centimeters. Now, we need to be careful when we put this into our calculators. We're dividing by pi, we're also dividing by 2. And so some people see this, which in a way it is. It's 4.5925 divided by pi times 2. That's fine if you put parentheses around that. What I do is 4.5925 divided by pi divided by 2. And if you're confused about that, we can talk in lab. So my calculator, I do the square root thing first. And then I got 4.5925 divided by pi. Just press the pi button. There it is. Divided by 2 equals. I'm thinking this should have 3 sig figs. 0.85493. Writing down 2 extras. And then I'm going to round. I'm going to round the 9. So this is going to come out to be 0.855. And what about those units? I had cubic centimeters divided by centimeters. So cubic centimeter is centimeter times centimeter times centimeter. So this one down here cancels one of those. And so now I've got centimeters squared, but I'm taking the square root. And so this comes out to be centimeters. Which is great because we're trying to find a radius, which is a length. Any questions?